Welcome, honors. Let's take a look at chapter 6, section 6. We'll be solving different types of equations today, exponential equations and inequalities, and logarithmic equations. So before we begin, you guys hop into Desmos, take about 10 minutes to practice log matching. Use your different properties of logs. Come on back when you're ready. All right, welcome back. Chapter 6, section 6, common powers. Probably want to put these in your notes, so that way you can have an easy, quick reference back to things. Common powers, such as 2 to the first, 2 squared, 2 cubed, 2 to the fourth, 2 to the fifth, and we could keep going. You're simply multiplying by 2 time and time again. We're doubling every time. For those of you that take computer science, binary code uses base 2, powers of 2. These are common units for things like memory or storage. We can also do powers of 3. This time we are multiplying by 3 every time. So it's another 3 that you're multiplying together. And you'll see things are growing faster because your base is 3. 2 to the fifth versus 3 to the fifth. Yes, we could do powers of 4. Multiplying by 4 every time. Some of these numbers ought to seem familiar because they're every other power of 2. Why? Because 4 is 2 times 2. And lastly, I guess we could do powers of 5. 5 to the first, multiplying by 5 again, multiplying by 5, multiplying by 5, multiplying by 5. So one type of equation that we're solving is an exponential equation where we can write things using the same base. And we'll get to that same base. To begin with, we're going to start solving this just like we would anything else. Take away 7 from each side. So we get 256 to the 2x equals 64. Now I look at the bases. I look at 256 and I look at 64 and I go, can I write those using a common base? Well, yeah, those were numbers that we found on our list. 256 is here, it's 2 to the 8th. 64 is here, it's 2 to the 6th. So if I replace my 256 with 2 to the 8th, I still have an exponent up here of 2x. I need to multiply that new exponent of 8 times that 2x. And on the right side, 64 was 2 to the 6th from your magic list. Once you have the bases that are the same, the bases drop out. This is the only time in high school that dropping out is a good thing. Your bases drop out when they're the same. We're left with 8 times 2x is 16x equals 6 because our bases drop out. Now we divide by 16. So x would equal 6 over 16, which, let's see, they're both even numbers. I can cut them in half and reduce them. That would give me 3 out of 8. If you want a decimal, take 3 divided by 8. You'll find that x is 0.375. How do you check your work? Take your answer, put it right here. We'll put this in our calculator when we work out the left side and press equal. It should turn out to be 71. So let me go ahead and try that on my calculator. We had 256. Exponent was 2 times 0.375 for x plus 7. Got 71. I know my answer is correct. Easy enough to check. Seeing how there's no questions, let's try another one. And in fact, let's work it out 2 different ways. 5 divided by 2 times 4 to the 4x minus 3 equals 37. My first step, add 3 to both sides. No matter how I'm working it out, I'm going to add 3 to both sides. What would you do next? Well, we need to get rid of that 5 halves that does not have the exponent. The 4 inside of the parentheses has the exponent of 4x, but the 5 halves does not have that exponent. So I can multiply by the reciprocal, which is 2 over 5, times 2 divided by 5, times 2 over 5, times 2 divided by 5. 2 over 5 and 5 over 2 cancel out. 5 cancels with 5, 2 cancels with 2, and we're left with 4 to the 4x equals, 80 divided by 5 would be 16. Oh, 5's gone. 4 to the 4x equals 16. So you look at that and you say, can I write it using a common base? Well, yeah, this is 4, and I can write 16 as a power of 4. So 4 to the 4x would equal 16 is 4 squared. Now that your bases are the same, the bases drop out, and you get 4x equals 2. Divide both sides by 4. 2 divided by 4 is a half. So over here, what if instead I didn't think of 4 as being my base? What if I thought of it as a 2? Well, 4 is 2 squared, but I still have this exponent of 4x. And then 16, we could write that as 2 to the 2, 4, 8, 16 would be 2 to the 4th. Once your bases are the same, the bases drop out. We get 2 times 4x is 8x equals 4. Divide both sides by 8. X is still 0.5. My point is this. You might not think of the same base that I did to work it out, but you can still come up with the same answer as long as you can write them both with the same base. You should be able to get to that same correct answer. If you want to check your work, take 0.5, plug it in here. 5 divided by 2. Parentheses 4 times 4 times 0.5, close your parentheses, minus 3, you get 37. Try it out. What did the 0 say to the 8? 0 say to the 8. Yeah, that's right. Nice belt. Get it? Why are bacteria so bad at math? Well, they multiply by dividing. Ah, get it? Cells divide. That creates more bacteria. They multiply. I'm right 98% of the time. The other 3% is when I have to solve math problems. I hope you get that one. All right, let's try this one. Same base. Minus 5. So 27 to the 6x equals 81. Now you start thinking, what number could I use as my base? Well, 27 is not an even number, so a power of 2 is probably not going to fit. It doesn't end in a 5 or a 0, so powers of 5 aren't going to work. But maybe a power of 3. Like 27 is 3 to the... It is 3 to the 3rd. You already have an exponent of 6x up here. We'll multiply by that. 81. 3 to the... 3, 9, 27, 81. 3 to the 4th. Once your bases are the same, the bases drop out. We multiply the 3 times 6x, get 18x equals 4. Divide by 18. 4 over 18. Well, we could reduce that. They're both even. Cut them each in half. 2 over 9, which is 0.222222222. You didn't know that one. Here you go. Here's a little trick for you. 1 divided by 9 is 0.1 repeating. 2 divided by 9 is 0.2 repeating. 3 divided by 9 is 0.3 repeating. What do you think 4 divided by 9 is? Absolutely. 0.444444. 5 over 9, 6 over 9, 7 over 9. So what is 9 over 9? Yeah, you're right, it's 1. I was hoping you wouldn't say 0.99999. Neat little trick though. You and your group take about, maybe 7 to 10 minutes tops working on the same base. Pause your notes, come on back when you're ready. So what happens when we have different bases? We aren't able to write this here and this over here using the same base. Well, we're still gonna solve it. We gotta get rid of that 1/2, so I will multiply by the reciprocal. The reciprocal of 1/2 is 2 over 1. So it's times 2 divided by 1. The 2 cancels with the 2, 1 cancels with the 1, and we're left with 5 to the 3x equals 65 times 2 divided by 1, 130. There's no way to write 130 using a power of 5. You have 5, you have 25, you have 125, and then it jumps to 625. So we have different bases. What do? Well, this is where our good buddy logarithm comes into play. We will take the log of each side. We'll take the log of the left and the log of the right. You have properties for logarithms. One property says when you add, you're multiplying. When you subtract, you divide. And another one says that when you have an exponent, it goes in the front. Well, guess what? We have a log, base 10, because it is invisible, of 5 to the 3x. That 3x is an exponent. This is my exponent. This is going to go out front. So 3x times, and sometimes we put the times, sometimes we don't. 3x times log of 5 equals log of 130. Log of 130 is just a number. You could use your calculator to get a decimal because it is base 10, but we can solve this and have an exact answer also. If we turn it into a decimal, it's an approximation. To solve, keep in mind, log of 5 is a number, log of 130 is a number. So my next step would be dividing both sides by log of 5. On the left-hand side, log of 5 will cancel with log of 5, leaves you 3x. Maybe I'll come over here. Right? On the right, log of 130 divided by log of 5. Log 130 divided by log of 5. How do you solve for x? Well, we need to divide by 3. Divide by 3. If I divide both sides by 3, I get log of 130 divided by 3 times log of 5. This is going to be tricky to put in our calculator. So what I really recommend you do, if you're going to get a decimal, before you write that exact answer instead, maybe what we should do is this. Let's put this in our calculator. Then we'll divide our answer that we get in the calculator by 3 to get x. All right, log of 130, be sure you close your parentheses, divided by log of 5. That gives you the right side of the equation. That's 3x is equal to 3.024369,199. Now, when you divide by 3, you'll have your answer. once we get to this step, you probably want to turn it into a decimal. Then we can divide by 3. Take it about 3-4 decimal places out and round. 3 would be minimum, 4 or 5 would be fabulous. We take that, we plug that number in here, we work it out, we should be able to get 65. So I'm gonna do that on my calculator, 1 divided by 2. Checking my work. Anytime we get a new type of equation, I always like to check it. I got my 1/2, 5 exponent 3 times my answer. That's the entire decimal. Why is it not exact? Because I rounded somewhere along the way. All right, let's continue on. You and your group, try your best solving exponential equations with different bases. You'll have to take the log of each side. Hit pause on your notes, take 10 to 12 minutes. Come on back when you're ready. Speaking of about 10 minutes, take about 10 minutes, go through Kahoot on logarithms, try your best. Then we'll finish up our notes. Welcome back. Last thing we're looking at today. Will be after your group work, after your Kahoot, solving logarithmic equations. To solve a logarithmic equation, we really need to go back to the definition of what a log is. We said that log base b of x is equal to y means, well, we learned that you have a loop method. B to the y equals x. Bye to your x. Say bye to your x. Bye. And if we keep that in mind, we can solve a logarithmic equation. I think these are probably the easiest ones yet. Log base b of x equals y means b to the y equals x. B to the y equals x. So if I have my base, it's an invisible 10 if I don't see a base. I can say 10 10 to the second power is equal to 5x plus 2. Excuse me. 10 to the second power equals 5x plus 2. Well, what's 10 to the second power? 10 to the second power is 100. Take away 2 from each side. Divide by 5. My answer, 98 over 5, which you can use your calculator to get a decimal for. 19.6. How do you check it? Well, your calculator does log base 10, right? So let's take that answer, plug it in, and see if it's right. Log 5 times my answer plus 2. That's what I was looking for. Left side turns out to be equal to the right side. I plug my answer in here, hit enter, it equals 2. I know I'm correct. Adam Sandler, comedian actor, said, "Don't judge a book by its cover. My math textbook has a picture of someone enjoying themselves on it. I did not enjoy myself at all." I'm guessing he's not a fan of math. How about relationship algebra? Ever looked at your ex and wondered why? Ooh, that's good. All right, last one. You try your best. Since you're not here, I'll have to read your mind and guide you through it. You have log of 6 plus log of 3x equals -1. Well, you have rules for logarithms. Adding means multiply, minus means divide, exponents are out in the front. Which rule applies when you have log of 6 plus log of 3x? It is multiply. So we will take this times this. Log of 6 times 3x would be 18x equals -1. Now it's just like the last problem we did. Put your imaginary base 10 in, loop around, pick up your exponent, and set it equal to our 18x. What is 10 to the negative first power? Okay. Ten exponent -1 is 0.1. Then you divide by 18. And there's our answer. You guys have 3 problems for homework. They are posted in Google Classroom. There they are. Exponentials. One of them might have the same base, one of them might be different, and then a logarithmic one. Good luck, have fun, see you next time. Bye, guys.